In problem 7, you throw a rock up, and you're throwing it up with a velocity, initial velocity of 11.67 meters per second. And if you release it 1.4, so this problem you're not releasing it on the ground because, well, that's not where your feet are on the ground, but when you throw something, you throw it from a little higher than that. So we got an initial Y position of 1.45 meters, about like that, right? How long will it take to the rock to land on the ground, right? How long will it take for the rock to land on the ground if you're throwing it up with this initial velocity? So there are a couple of ways to go at this. One is, what do we have in terms of our overall equation? Y is minus 1/2 gt squared plus v naught t plus y naught. So we have this equation. Y is minus 1/2 gt squared plus v naught t plus y naught. And we know everything in there, right? We know g is 9.8 meters per second squared. So we know g, we know v naught, we know y naught. What's y? Y, when it hits the ground, is what? Y goes to 0. So y is 0. We're looking for when it hits the ground. So there are a couple of ways to go at this problem. The one that seems the most straightforward is I'm going to just take this. This is a quadratic equation. Well, that's 0. So we got 0 is minus 1/2 gt squared plus v naught t plus y naught. It's a simple quadratic equation. We could put in the quadratic formula. T is then going to be minus b plus or minus the square root of b squared minus 4ac over 2a. And so you can go and you can do this, and you'll get an answer. There are two, of course, and the two answers correspond to two different physical things. So here's the ground, and I'm going to draw this in a parabola because it's kind of hard to go just straight up and down and tell you what I'm talking about. So this goes up, and it comes back down. So the solution you want is the time it takes to do this. But the other solution is the time it takes to go backwards in time, that distance. All right, so you could easily go backwards in time and say, when did it come up from the ground to hit this point at 0 time going the velocity it is? The other way to look at this problem is very simple. First, let's figure out how long it takes to get to the top. How long does it take to get to the top? Well, that's pretty straightforward. Why? What's its velocity at the top? 0. All right? And we know velocity is, in this case, minus gt plus initial velocity. Well, we know the velocity at the top is 0, so 0 is minus gt plus your initial velocity. And so the time, solving for time is just your initial velocity over the acceleration of gravity. Now you know how long it took to get up here. Next question, how high is it when it gets up there? Well, y, we know the time. Y is minus 1/2 gt squared plus v naught t plus y naught. We can just stick it into this equation and find out how high it is. I'm just going to call that h. That's h. Once we know how high it is, once we know where it is when it gets to h, then the next piece is to figure out, right, now we've figured out h, the next piece is to figure out how long does it take to fall. Well, that piece is also pretty easy. Why? Once you're at the top and you're sitting still, y, which is h, right? Let me just go ahead and put h. Oh, that's our initial position. What's our initial position? Our initial position is now h. What's our final position? 0 is minus 1/2 gt fall squared. What's our initial velocity? 0 plus h, right? So the velocity term is gone because we're going 0 velocity initially at the very top. We can solve this for the time it takes to fall, right? And so t fall is just going to be 2h over g square root. All right? So we know how long it takes to fall. We know how long it takes to get to the top. We just add the two together and we get the answer. Any problems? No? Okay. All right. Good luck with this problem. One little further point. This piece right here is minus b over 2a is v naught over g. Minus b over 2a is v naught over g. And then the plus or minus piece. The plus or minus piece is how long it takes to fall. So t fall is plus or minus square root of b squared minus 4ac over 2a. So what is this saying? Well, you go to the top, and either you go forward long enough to fall, and that tells you how long the whole trip is, or you go backwards in time, back to the ground over here, and that tells you how long it would have taken going backwards in time to go from here to here. All right, see you next time.